Hello everyone, this is Infinitive Vision and my name is Rehan Nawaz. This is the sixth lecture on ratio and our fourth session on art of problem solving. So we will be exploring more questions to understand this art better. Let's look at this problem, that is practice problem 22. The question reads, solve the following equations. The first equation being 7yz plus 3zx equals 4xy. And the second equation reads 21yz minus 3zx equals 4xy. And your third equation is x plus 2y plus 3z equals 19. Now if I notice, in the first two equations you have yz, zx and xy. And in the third equation you have xyz. So how we are going to handle that? What we are going to do, we are just going to first write or rearrange the first equation, and I can say this is nothing but 7yz plus 3zx minus 4xy equals to 0. And my second equation would be 21yz minus 3zx minus 4xy equals to 0. Now, if I divide both the equation by xyz, let's say if I divide both the equation by xyz, I can divide it by xyz, xyz, xyz. So each term would be divided by xyz. This equation can also be divided by xyz, xyz, and xyz. Why did I divide it? Because you will notice that there would be things which could be cancelled. That is, this yz would be cancelled by this yz. This zx would be cancelled by this x and z. And this xy would be cancelled by this xy. Again, you can cancel this yz by this yz, this zx by this xz, and this xy by this xy. Now what you have seen that you have converted these two equations, which was in yz, zx and xy, into a form of new equation, which is nothing but the first equation is 7 by x plus 3 by y minus 4 by z equals to 0. That is your first equation. And the second equation is 21 by x minus 3 by y minus 4 by z equals to 0. Now since I can say for these two equations I can consider 1 by x, 1 by y and 1 by z as our three variables, and then again it follows that I am considering these two equations in the format of ax plus by plus cz equals to 0. So what we can do, we can simply apply the cross multiplication method, and in the numerator I can write 1 by x, 1 by y and 1 by z, and divided by the cross multiplication coefficient. And how do we find the cross multiplication coefficient? You see, 1 by x, 1 by y and 1 by z are in the order. 1 by x, 1 by y and 1 by z are in the order. So I'll simply write the constant. So if I hide my 1 by x, I'll get the constant as 3 and minus 3. For the second, I'll get minus 4 and minus 4. And for third, we'll get 7, 21. And then I'll finish it with 3 and minus 3. What is going to be the first term? This is going to be 3 into minus 4 and then minus 3 into minus 4. That is minus 12 minus 12, which is nothing but minus 24. So I can simply write this is minus 24. What about the second guy? Minus 4 into 21, that is minus 84. And minus 4 into 7 is minus 28, minus minus plus. So minus 84 plus 28 is minus 56. And the last guy, 7 into minus 3, that is minus 21. Minus minus 63, that is minus 84. Now if you notice, you will see that all the three has minus, so minus can be cancelled. Now what we can do further, we can say 4 6 are 24, 4 14s are 56, 4 21s are 84. And now I can say everything is equivalent to lambda. So what I can say, my 1 by x is 6 lambda, my 1 by y is 14 lambda, and my 1 by z is 21 lambda. Now what we can do? We can simply write my x is nothing but 1 by 6 lambda. My y is nothing but 1 by 14 lambda. And my z is nothing but 1 by 21 lambda. Now I have my x, y, z in terms of 1 by lambda, which I am going to put in my third equation. So x would be replaced by 1 by 6 lambda plus 2y. Y would be replaced by 1 by 14 lambda, and my z, 3z, so z would be replaced by 1 by 21 lambda, and these all are equivalent to 19. Now 2 will cancel this, it will become 7. 3 will cancel this, it will become 7. So you have 1 by lambda common, 1 by 6 plus 1 by 7 plus 1 by 7 equals to 19. So your 1 lambda, I'll just add these fractions. So you can say this is nothing but 42. So here you have 7, 6, 6 equals to 19. So your 1 by lambda is nothing but 42 into 19 divided by 19, because 7 plus 6 plus 6 is 19. So 1 by lambda is nothing but 42. So what we can say, my x is 1 by 6 into 1 by lambda, and my 1 by lambda is 42. So 1 by 6 into 42 is 7. So my x is 7. What about y? My y is 1 by 14 into 1 by lambda, and my 1 by lambda is 42. So 1 by 14 into 42, that is 3. So my y is nothing but 3. And what about my z? My z is 1 by 21 into 1 by lambda, and my 1 by lambda is equivalent to 42. So what will be the answer? You will say 21 2s are 42. So my z is nothing but 2. So the solution for these equations are going to be x equals to 7, y equals to 3, and z equals to 2. Let's look at this problem, that is practice problem 23. The question reads, solve the following equations. The first equation is 3x square minus 2y square plus 5z square equals to 0. The second equation is 7x square minus 3y square minus 15z square equals to 0. And the third equation is 5x minus 4y plus 7z equals to 6. Very similar to our previous question. In this, we are just going to do the same approach. We are going to follow the cross multiplication method, but the variable we are going to use as x square upon y square upon z square upon. Now for cross multiplication method, we will be following the same routine, that we will just hide the first two terms. You have minus 2 minus 3. Then you have 5 and minus 15. Then I'll follow the cycle. This is 3 and 7. And then minus 2 minus 3 from where we began. We are ending with that. Minus 2 into minus 15 is 30. Minus of minus 15 is plus 15, that is 45. So I'm just going to write 45 here. What about the second guy? 5 into 7 is 35. And minus of minus 15 to 3, that is plus 45, that makes it 80. And what about the third? 3 into minus 3, that is minus 9. And 7 into minus 2 is minus 14, minus minus plus, so this would be plus 5. Now 5, 45 and 80, 5 can cancel each other, so this will become 9, this will become 16, and this would become 1. I can say everything is equivalent to, let's say, lambda square, because we have x square, y square and z square as a square term. So I just wrote a positive quantity there. Now I can say x square is nothing but 9 lambda square. Your y square is nothing but 16 lambda square. And your z square is nothing but lambda square. Here I have 5x minus 4y plus 7z equals to 6. So I'll just try to write x is nothing but plus minus 3 lambda. y is nothing but plus minus 4 lambda, and z is nothing but plus minus lambda. So I'll try to put plus 3 lambda, plus 4 lambda and lambda in this equation. So for x, I'm going to write 5 into 3 lambda minus 4 into 4 lambda plus 7 into lambda equals to 6. From this, I can say this is nothing but 15 lambda minus 16 lambda plus 7 lambda equals to 6. 15 plus 7 is 22. 22 minus 16 is 6 lambda. So 6 lambda is equal to 6. So your lambda is nothing but 1. So if I get my lambda as 1, so one solution could be that x is 3, y is 4, and z is 1. This could be my one set of equation solution. What about if I pick the other solution, that x is equal to minus 3 lambda, y equals to minus 4 lambda, and z equals to minus lambda. So if I put it here, I'll get 5 into minus 3 lambda minus 4 into minus 4 lambda plus 7 into minus lambda equals to 6. What we have minus 15 lambda plus 16 lambda minus 7 lambda equals to 6. So you have minus 22 lambda plus 16 lambda, that is minus 6 lambda is equal to 6. Your lambda becomes minus 1. Now when you try to put minus 1 in this equation, you will again get x into minus 3 into minus 1, that is 3. Y is equal to minus 4 into 1, that would be 4. And z would again become 1. So again you got the same solution. So no matter you take the lambda as positive or negative, the answer would come out to be 3, 4, 1. Let's look at this problem, that is practice problem 24. The question reads, if L upon under root A minus under root B plus M upon under root B minus under root C plus N upon under root C minus under root A equals to 0, and L upon under root A plus under root B plus M upon under root B plus under root C plus N upon under root C plus under root A equals to 0, then you have to show that L upon A minus B into C minus root AB equals to M upon B minus C into A minus root BC equals to N upon C minus A into B minus root AC. Now this question looks little difficult to tackle, but if you have little patience, you would understand that this is nothing but solving two linear equations with three unknown, and we can easily find their proportion. For that, you just need to understand that of course they have given you the irrational expressions, but when you see that they are also in cyclic form, that you have AB, then you have BC, then you have CA, right? So if I try to write the cross multiplication multipliers, so I'll begin with the second term coefficient, and this would be 1 by root B minus root C, 1 by root B plus root C, right? This is how we will begin. And the second guy would be 1 by root C minus root A, because it's going to be following the very cyclic nature, and then 1 by root A minus root B upon 1 by root A plus root B, and will end with the term where we began, root B minus root C upon root B plus root C. Now for the first coefficient, you would notice that you have to multiply these two minus the product of these two. Now when I look into this, 1 upon root B minus root C multiplied with 1 upon root C plus root A minus 1 upon under root C minus under root A into under root B plus under root C. Now this look little difficult, but if you have little patience, you would be able to arrive to a very symmetrical result. That you have a rational expression where denominator is this, minus rational expression where the denominator is this. Whenever you have to subtract two rational expressions, you just need to find the LCM of their denominators. So we can simply multiply these two together. So when root b minus root c will be multiplied with root b plus root c, that would become b minus c, because you know a plus b into a minus b is a square minus b square. So what I can say, root b minus root c into root b plus root c would be the square of root b minus square of root c, which makes it b minus c. Something very easy. At the same time, root c plus root a into root c minus root a will make it c minus a. Again, easy to guess, right? Now what we need to do, we need to put the multiplication or the product of these two in the first term of the numerator. So root c into root b, I'll just multiply. Root c with root b will become root bc. And root c plus root c would become plus c. Minus root a into root b would become minus root ab. And minus root a into minus root c plus root c will become minus root ac. So this would be the first term of your numerator, because I just multiplied root c with root b, that is root bc, root c with root c, that is plus c, minus root a into root b minus root ab, minus root a into root c minus root ac. Now I need to put subtraction here, and what I'll get, I'll just multiply these two and put it there. So root b into root c, that makes it root bc, and root b into root a makes it root ab, and minus root c into root c make it minus c, and minus root c into root a makes it minus root ac. Now you can easily see what all are getting cancelled. Root bc will cancel this root bc out. Minus root ac minus root ac will cancel these two out. C minus c will make it 2c. And minus root ab will make it minus 2 root ab upon b minus c into c minus a. Now, let's say if you have to multiply these two, you don't need to do all the calculations now, because now you have already saw the format of how these two are happening. So I can say the second coefficient would be, let's first write the denominator. You see root c minus root a and root c plus root a. So definitely it will be c minus a. And then you see root a minus root b, then root a plus b. So definitely it would be a minus b. I see here minus c and c, then 2c. So it would be 2a. And then minus 2 root. Since I have got c here and here a, the remaining is AB, so here the remaining would be BC. The second coefficient would be this. What about the third? Let's look at. This will go with this. The cycle will continue. So you can simply say the third guy would be, you have root a minus root b and root a plus root b. So in the denominator you will have a minus b. And root b minus root c and root b plus root c, you will have b minus c. Here you have minus b, then plus b, so you can write 2b by following the structure. And then minus twice of b has been taken care of, so it would be ca. So I can write the whole thing, these two, L upon, my first guy is 2c, that is twice of c minus root ab. What we have in the denominator, we have b minus c into c minus a, so it would be b minus c into c minus a in the numerator, equals to m upon, what we have as a second term, twice of a minus root bc, and then in the denominator it is c minus a into a minus b, so which will go into c minus a into a minus b, equals to n upon, what we have as a third guy, twice of b minus root ca, and in the denominator will go in the up, a minus b into b minus c. Now what we can do? We can simply say that 2, 2 and 2 can be out. Here I see b minus c into c minus a. Here I see c minus a into a minus b. And here I see a minus b into b minus c. So what I see that you have two fellows of a minus b, b minus c and c minus a taken together. So what we can do, I can simply divide the whole ratio by the product of a minus b, b minus c and c minus a. So if I divide it in the denominator, if I write a minus b into b minus c into c minus a, and the same way in this denominator I'll write a minus b into b minus c into c minus a. In the same way I'm going to write here a minus b into b minus c into c minus a. What I can do? I can cancel the common thing. So b minus c and b minus c will be out. C minus a and c minus a would be out. C minus a would be out. A minus b and a minus b would be out. B minus c and b minus c would be out. A minus b and a minus would be out. So what I'll be able to write? I'll be able to write that L upon c minus root ab into a minus b, which is also equal to m upon a minus root bc into b minus c, which is equivalent to n upon b minus root ca into c minus a, which is nothing but the same expression which we had to prove. So this equation looked difficult to prove, but we just had to have little patience in finding the first term of this cross multiplication coefficient, and then you knew that everything would follow the cycle. So you could have easily guessed what would be the other coefficients for cross multiplication method. So just a patience and little bit of idea that how cyclic expressions work, you would be able to solve this problem easily. Let's look at this problem, that is practice problem 25. You have to solve the following equations. The first two being ax plus by plus cz equals 0 and bcx plus cay plus abz equals 0. And the third equation is xyz plus abc into a cube x plus b cube y plus c cube z equals 0. Now, if I try to solve these two equations, you can say I can easily find at what proportion xyz is by simply cross multiplication method. So x upon y upon z upon, the multipliers are going to be, the first two is going to be bca, so you're just going to write bca, then you're going to write cab, then you are going to write abc. You will see the cycle is being followed, and then it's going to be end with bca. So you can say this is going to be ab square minus ac square. So I'll just write a into b square minus c square. For b, I'm going to write bc square minus ba square. So b into c square minus a square. And for this, I'm going to write c into a square minus b square. For this, I can write my x is lambda a b square minus c square. My y is lambda b c square minus a square, and my z is lambda into c into a square minus b square. Now I'm going to write my xyz in the third equation. So my xyz would become lambda, so this will become lambda cube. ABC, so this will become ABC. And then I have the cycle b square minus c square into c square minus a square into a square minus b square. Plus, I got ABC, so I'll just write ABC. Here I got a cube x b cube y, c cube z. So I know in each x, y, z I have lambda, so I'll take lambda out. And inside I'll get a cube into a into b square minus c square, which means a to the power 4 b square minus c square. Then b to the power 4 c square minus a square. And then c to the power 4 a square minus b square. It will follow the structure or symmetry or cycle, what you want to say. Now what I can see that ABC is common. So ABC can be out. Lambda can be taken out, so it will become lambda square. Now if I look here, this is nothing but a to the power 4 into b square minus c square plus b to the power 4 into c square minus a square plus c to the power 4 into a square minus b square. Very cyclic expression. But if you notice, if you replace a with b, so wherever you see a, if you replace b, if you plug b here, so it would become b to the power 4 into b square minus c square and b to the power 4 plus c square minus b square. You would notice this would evaporate and this would evaporate. So the whole expression would become equal to 0. You would notice the same thing for b equals to c. You would notice the same thing for c equals to a. And then you would notice it is true for a equals to minus b also, b being replaced with minus c and c being replaced with minus a. What does it suggest? It suggests that this 6 degree expression, because you have power 4 and then 2 power 2, so 2 degree into 4 degree would make it a 6 degree, has 6 factors, and these factors are nothing but a minus b into b minus c into c minus a into a plus b into b plus c into c plus a. So I can factorize the whole story into a plus b into b plus c into c plus a into a minus b into b minus c into c minus a. But definitely this is a 6 degree expression and I have written the 6 linear factors, but still I am not sure whether it has any constant outside or not. So for that, what we need to see, that we know the term, let's take this term a to the power 4 b square. If I notice a to the power 4 b square, this is a positive expression in this, right? This is a positive expression in this. Now if I have to build the same a to the power 4 b square here, I need this a, I need this a, I need this a, and I need this a, and then I need this b, and then I need this b. Then only I would be able to create my a to the power 4 b square. So let's say if I multiply a with b, ab, and b with a into a, then into a, then into b, then minus a, because the last guy is minus a. So I am getting minus a to the power 4b square. What does it suggest? That okay, this expression can be factored into a plus b into b plus c into c plus a into a minus b into b minus c into c minus a, but you need to put minus sign ahead of it, because the term here you got a to the power 4b square and here you are getting minus a to the power 4b square, and you would see that this is happening for each of the term you are building. If you look into minus a to the power 4c square, you will see it is making a to the power 4c square. So you can cross verify with any two terms and you would be seeing that okay, you need to put minus sign here. You need to put minus sign here. So the whole equation, I'll just rewrite it, has become lambda square into, this can be broken as b plus c into b minus c, c plus a into c minus a, because you know what is the formula for a square minus b square. It would be a plus b into a minus b, and the expressions which we have factored would be plus minus a plus b into b plus c into c plus a into a minus b into b minus c into c minus a equals to 0. So the whole expression would become lambda square into b plus c B minus C, C plus A, C minus A plus B, A minus B equals to A plus B, B plus C, C plus A minus B, B minus C, C minus A, because the minus guy, when you will transform it to the right, it would become plus and the whole expression would cancel. This would be cancelled with this and you would be getting lambda square is equal to 1. You would be getting lambda square is equal to 1. So what would be your lambda? Your lambda would be plus minus 1. Your lambda would be plus minus 1. So what are going to be your x, y, z? So your x is going to be plus minus a under root into b square minus c square. This is going to be your x. Your y is going to be plus minus b into c square minus a square, and your z is going to be plus minus c into a square minus b square. So this is how we solve these type of cyclical problem. Now let's read this problem, that is practice problem 26. You have to solve the following equations: ax plus by plus cz equals 0, and a square x plus b square y plus c square z equals 0, and x plus y plus z plus b minus c into c minus a into a minus b equals to 0. Now for that we will be following the same routine. We'll just try to write what we have as x upon y upon and z upon, and we are going to do the cross multiplication. So the first guy would be b square, then we'll have c square, very symmetrical, then a square, and then it will end with b square. So this would be bc square minus b square c. bc square minus b square c makes it bc common, and then c minus b. For the second guy we have ca square, so ca would be common, so ca into a minus c, and your z would be ab square minus a square b, so you can take ab common, so it would be b minus a. Now I can say this whole thing is equivalent to lambda, so your x would be lambda bc c minus b, your y is lambda ca a minus c, and your z is lambda ab b minus a. Now I'll just put this whole thing here. So your x would become lambda into, what's your x? You have bc into c minus b, and the y is lambda into ca into a minus c plus lambda ab into b minus a plus b minus c into c minus a into a minus b equals to 0. Now what we can do, if you notice here, lambda is common, so I'll just take out lambda common, and here you can say bc into c minus b plus ca into a minus c plus ab into b minus a plus b minus c into c minus a into a minus b equals to 0. Now if you notice, this is 1 degree, 1 degree, and then 1 degree. So basically this is a cubic expression and very symmetrical, or very cyclic in nature. What we can do, if we say that if I replace a with b, what happens? So this first term will remain bc into c minus b, no problem with that. I'll replace a with b, so the second term would become cb into b minus c, and the third term would evaporate, and again I see bc and cb common, so it will cancel out. So I can say the whole expression would become 0. So I can say this is a minus b is one of its factor. Now if I replace b with c, I would notice the same thing. If I replace b with c, I can say this, the factor would be b minus c. And if I replace c with a, again I will see the same thing. So I can say c minus a is also a factor. Now the question is, you have a 3 degree and these are your 3 linear terms. Do you have any constant outside? For that, what you can do, you can pick any term like we did in the last problem. Let's say we are going to build BC square. So this is how we are going to build BC square. You have only BC square here. Now if I have to build BC square, what I can do, I can take this C, this minus C, and then this minus B. This will help me build my BC square. So if I say minus B into minus C, that is plus BC, then again BC into C, that is going to be BC square. Okay, so we have BC square here also and we have BC square here also. So I can successfully say that the whole story can be broken as lambda into A minus B into B minus C into C minus A plus B minus C into C minus A into A minus B. Now you know lambda into the expression plus same expression equals to 0. So you can say lambda into A minus B, B minus C, C minus A equals to minus of B minus C, C minus A minus B, which suggests that lambda is going to be minus 1. And when I know my lambda is minus 1, I can rewrite my answers because my x is nothing but lambda into BC into C minus B. So my x would become, I will replace lambda with minus 1. So the answer would become BC into B minus C, because here I have C minus B. So it would become B minus C. My y would become ACA into C minus A, because minus 1 would go and make A minus C as C minus A. And my z would become AB into A minus B. A very symmetrical answer. So I'm sure you understand the beauty of symmetry and cyclicity. You understand that how ABC or XYZ are interchanging, and you can predict the next terms simply by looking that the cycle is being repeated. Let's look at this problem, that is practice problem 27. The question reads, if A into y plus z equals x and b into z plus x equals y and c into x plus y equals z, then you have to prove that x square upon a into 1 minus bc equals y square upon b into 1 minus ca equals z square upon c into 1 minus ab. For that, what you are going to do? You are going to see that, okay, first I am going to write these 3 linear equations in a right order, means the first term as x, the second term as y, and the third term as z. So this whole thing would become minus x, because x would be gone to the left, minus x plus ay plus az. This is my first equation. The second equation would be bx minus y plus bz. Very symmetrical. And the third would be cx plus cy minus z equals to 0. I'll try to first write the proportion of x, y, z using these 2 equations. So this would be x upon y upon z upon. I'll just hide my x. I'll get ab minus minus a, which makes it ab plus a. Right? I'll get AB plus A. You can simply see. I'll just hide it. AB minus minus A. Now, this A will go with this. That is going to be AB minus of minus B. That is plus B. What about the Z? Minus 1 into minus 1 is 1. 1 minus AB. So, this is the first guy we got. Now, we are going to look into these 2 together, and if I look into these 2 together, I can write x upon y upon and z upon. For this, what we can do, minus 1 into minus 1 is 1, minus BC. For y, we are going to do B with C, that is BC, minus of minus B, that is BC plus B. And below Z, I'll get BC plus C. Right, very easy. Now, I'll pick the first one and the third one, and then I'm going to write my x upon y upon and z upon. For this a will go with minus 1, that makes it minus a, and then minus ac. So minus, I'll common a plus ac. For y, we are going to put y as this. So this a would go with c, that is ac, and this would become minus 1. Minus 1 into minus 1 is plus 1. So ac minus 1. So I can write 1 minus ac with minus sign, right? You can see this a will go with c, and this minus 1 into minus 1, that is plus 1. So ac minus 1, which I have written as minus of 1 minus ac. And for the last guy, minus 1 into c is minus c minus ac. So I'll just write c plus ac. So this minus can be removed. Now I need to prove that x square upon a into 1 minus bc, x square into a into 1 minus bc equals to y square into b into 1 minus ca is equal to z square upon c into 1 minus ab. What I have to notice that below x square I need 1 minus bc. For this I am going to use this. And then I also need a, so I'll just pick this. And when I look into these two, I can say below z I get 1 minus ab, so I'll just multiply these two. So this is equal to this and this is equal to this. If I multiply these two, the product would be equal, because x into x will make it x square upon ab plus a would be a into 1 plus b, and then I'll get 1 minus bc, and below z I'll get z into z, that is z square, 1 minus ab, that's okay, and then the second guy is going to be c common and then 1 plus b. What you notice that 1 plus b and 1 plus b would be cancelled, and now you can say that this ratio is equal to this ratio. So we have done the half part of the problem. Now let's say I'm going to compare the y square part. So I'm going to pick this equation, y upon 1 minus ac, and then I'll pick with this, let's say, and then I'll pick this with this. So I can say y into y is y square upon, here I see 1 minus ac, I'll write 1 minus ac, and then here I got b into 1 plus a, so I'll write b into 1 plus a. I picked z, so z into z would become z square, 1 minus ab into c plus ac, so I'll just write 1 minus ab into c plus ac is nothing but c into 1 plus a, and now I can say that this 1 plus a would cancel this. So this is also equivalent to this. So we have proved these two equal and we have proved these two equal, hence the whole continued ratios are equal. Let's look at this problem, that is practice problem 28. The question reads, if ax plus hy plus gz equals 0, hx plus by plus fz equals 0, and gx plus fy plus cz equals 0, you have to prove that first part, x square upon bc minus f square equals to y square upon ca minus g square equals to z square upon ab minus h square. And the second part is bc minus f square into ca minus g square into ab minus h square is equal to fg minus ch, gh minus af, and hf minus bg. For this, you just see that you have 3 linear equations and 3 unknown. So we'll be following the same pattern. We'll first take these 2 equations and we'll write them in the right order so that we can write at what proportional our x, y, z is. So I'll write ax plus hy plus gz equals 0 and hx plus by plus fz equals 0. For writing the multiplier for cross multiplication, I'll write h, then b, then I'll write g, then f, then I'll write a, then h, then I'll write h and b, right? So the first relation I'll get x upon y upon z upon. For this I can say this is hf minus bg. This is gh minus af. And this is ab minus h square. We'll be doing the same story between hx by fz and gx fy cz. For this, I'm going to write b f h b f c g f. For these two, the second and the third, again I'll write x upon y upon z upon. Considering these two, again I'll write my proportionality. For this, this is going to be bc minus f square. This is going to be fg minus ch. And this is going to be hf minus bg. Now the final part, the first and the third. Let me clean this up. For writing the multiplier for cross multiplication, I am going to write f c g f, and for this I am going to write h g ah. So the first guy would be fg minus ch, so x upon fg minus ch, and y upon ac minus g square, and this is going to be gh minus af, z upon gh minus af. Now I need to create x square upon bc minus f square. For that, I am going to take this x and I will multiply with this. So I'll get x square into bc minus f square into hf minus bg, and I am going to take this z and this z. What you will notice, x into x is x square upon hf minus bg into bc minus f square equals to z into z, that is z square upon ab minus h square upon into hf minus bg. You notice that hf minus bg is common, so they would be cancelled, and you can say that this is equivalent to this, as we have done in the previous problems. In the same way, we have to develop the y square. For this we can say y into y, and I'll pick x into x. So you will notice that y square has ac minus g square into fg minus ch, and x square has bc minus f square into fg minus ch. You will notice fg minus ch and fg minus ch would cancel each other out. Then you can say this is also equivalent to this. So you know these two are equal, you know these two are equal, so all the three would be equal, a very simple thing. Now the second part is, what you need to understand, that you need to have bc minus f square, ca minus g square, and ab minus h square together. And let's say my first set, this is equal to, let's say, p, this is equal to, let's say, q, and this is equal to r. So what I can see, that my z is p into ab minus h square And if I took here, my x is q into bc minus f square, and my y is r into ac minus g square. Now if I multiply them up, I can simply say my x, y, z is equivalent to p, q, r into ab minus h square, bc minus f square, and ac minus g square. So this is one equation I created. Why did I do this? Because I wanted to have a product of ab minus h square, bc minus f square, and ac minus g square. Now what I need is, I need fg minus ch, and I need gh minus af, and I need hf minus bg. So let's say, for here I take this one, and I write y is p into hg minus af. And for x I want fg minus ch, so I take this and I write x is equal to r into fg minus ch. And for z I take this and I write z is q into hf minus bg. So now I have created my x, y, z again in terms of fg minus ch, gh minus af, and hf minus bg. Now if I try to multiply these equations, I'll get x, y, z into p, q, r, because we have p, q, r together, and then you will have for x fg minus ch, from y you have hg minus af, and for z you have hf minus bg. You would notice that these two equations has same left hand side, so you can say these two are equal. And when you say these two are equal, PQR and PQR can be cancelled, and you can say, okay, these two are equal, which is nothing but your statement 2. So this is how we solve problems related to ratio. As you see, we began with a very basic problems, easy problems, direct problems, and then we slowly started solving some complicated problems. And you know that for solving any complicated problems, you needed to go to the basics, you needed those tools, and you needed the idea that how symmetry works, how cyclicity works, and how things can be sorted out if things can be sorted through organizing. So what we learned through these 4 sessions on problem solving, we learned that whenever you have to solve any problem or you encounter any mathematical problem, you should always begin by reading the question properly. And once you read the question properly, you understand the demand, you understand what exactly the structure is, you understand what information can be extracted, and you have already a theoretical background that what all concepts can be brought together as a brute force or as a force, a sophisticated force, which can help you connect all the information you have and what exactly is the demand of the problem. And the art of connecting these two is nothing but the art of problem solving, which we learned through these 4 extensive sessions